everybody, welcome back to our channel kaviwebdesigns, and today I'm going to tell you about the next chapter in this training course, which is chapter number 3, IP addressing and subnetting. So previously we have done chapter number 2, which is networking models. Now here we're moving on to the next chapter, which is chapter number 3, IP addressing and subnetting. IP address is a unique identifier for each device on a network. It helps in communication between devices. Here are two main types of IP addresses. Number 1, we have IP version 4, and number 2, we have IP version 6. IP version 4 is a 32-bit address composed of 4 octets. For example, like 192.168.0.1, with each octet ranging from 0 to 255. Now here we have IP version 6, a newer version that uses 128-bit for much larger address space. So here IP version 4 addressing structures and classes. An IP version 4 address is a 32-bit number, typically used in dotted decimal format consisting of 8 octet or 8-bit segments separated by dots, for example like 185.107.80.231, and each octet has a value between 0 to 255. Now let's see what is the IP version 4 address format. So as you can see here we have a IP version 4 address. Here each of these numbers are a octet and they represent a binary code, and each octet is equal to 1 byte or 8 bits. And all of these 4 integers will get until 4 bytes, which is 32 bits. Now let's see the IP addresses. So here in the example IP address, the first 3 decimals are all the network addresses, and the last number is the host address. So as you can see here we have 192.168.1.2 as an address. Now as you can see here, these 3 numbers are going into one segment, which is the network address segment, and this last number, which is 2, is the host address, and all of them combined will be equal to 32 bits. Now let's go to our next slide. So what are the classes of IP version 4 addresses? IP version 4 addresses are divided into 4 classes: A, B, C, D and E, based on the range of values in the first octet. So here in class A, it ranges from 126, and class A is used for very large networks. And here we have class B, which is 128 to 191, which is used for medium-sized networks. Now let's move on to class C, which is 192 to 223, which is used for small networks. And let's move on to class D and E. So class D is from 224 to 239, and it is used for multicast groups. Now let's move on to class E, which is until 240 till 255, and it is reserved for experimental uses. So as you can see here in this diagram here I have got a table for you ranging from class A to class E. So as you can see here it starts from 0 all the way to 200, all the way to 127, 128 to 191, 192 to 223, 224, 239, 240 to 255. Now let's move on to the next slide. Now let's see what are the structures and classes for IP version 6, which is IP version 6 addressing. An IP version 6 address, Internet Protocol version 6, uses a much larger address space, allowing for a virtual unlimited number of unique addresses. So here is the structure of an IP version 4 address. An IP version 4 address is a 128-bit number, typically used to represent in hexadecimal format, separated by colons, for example, like this large string, which is a IP version 6. The expanded form of an IP version 6 can be written in full like this. And the types of IP version 6 addresses are number 1 unicast, number 2 multicast, number 3 anycast. Unicast is a unique address for a single network interface used for one-to-one communication. Number 2, we have multicast. Multicast is an address that allows to one-to-many communication, sending data to multiple hosts in a single transmission. Now here we have number 3, which is anycast. Anycast, an address that is an address that is assigned to multiple interfaces with packets routed to the nearest one. So as you can see here in these two diagrams, here in the first diagram here is a long structure of the IP version 6 address. So as you can see here, then the first 3 decimals are all 48 bits and they are the global prefix. Here in the 4th decimal, here it is only 16 bits and it is a subnet. So if we combine global prefix and subnet together, it will turn into 64 bits. And here the last 4 decimals here are the interface ID. And interface ID combined all together will turn out to be 64 bits. And 64 plus 64 is 128 bits. So that's why IP version 6 is a 120-bit address. Now, as you can see here in the second IP version 6 address, here we have the types of IP addresses. Here, number 1, we have IP version 6 unicast addresses. We have multicast addresses, and we have linked local addresses, unique local addresses, anycast addresses also. So let's move on to the next slide. So here in the next slide here we have public versus private IP addresses. Public IP addresses. These are globally unique and are used to identify devices on the network. So here, let's move on to the private IP addresses. These are reserved for users within private networks and are not routable on the network, on the internet. Common private addresses ranges include these. So as you can see here these are IP version 4. So 10 all the way to 10, 255, 255, 255 and 255. So as you can see here, these are all private IP addresses. Now let's see what's in the diagram here. So here in the diagram, here from the internet, we get the internet from the router here, and the router has a public IP, which is, as you can see here we have a public IP for the router. So the router gets the internet from the internet and then gives it to our unique IDs or the private IDs that we own. Now let's move on to the next slide. So here in the next slide, here we have subnetting. Subnetting divides a larger network like 135.70.0.0 into smaller subnetworks such as 135.70.2.0 and 135.70.3.0. This allows for organizations and management of IP addresses, as well as more efficient routing within the network by using a subnet mask. Devices within each subnet can communicate with each other directly, while communications between different subnets goes through the router. So here we have the internet and server. At the top of the diagram here, the internet is connected to a server. So as you can see here in this diagram here, the internet is connected to a server. This is the starting point where data and communication originate from. So these two parts handle the communication and data where it's getting sent. And here, moving on to the routers. The routers act as an intermediary between the server and the different subnetworks. They help route traffic to the correct destination by splitting the network and host portions of IP addresses. So as you can see here the router, otherwise known as the subnet mask, the router will split itself into 2 other host IP addresses. So as you can see here we have the host IP address 135.70.1.0, and here in the other network IP addresses, here we have 135.7.70.3.0. Let's move on to the subnet mask. The subnet mask splits IP addresses into host and network portions. As I told you before, here the subnet mask will split IP addresses into the hosts are these two here, and network addresses. This allows devices in different subnetworks like 135.70.2.0 and 135.70.3.0 to be identified as part of the same overall network but grouped separately. Now let's move on to the IP addresses structure. The IP addresses structure in the diagram has a network portion like 135.70.x.x. That means 135.70 is the IP address for all of these, for these routers, the subnet mask, and all of these devices here. And a host portion specifically to devices like 135.70.2.2 and 135.70.3.1. 135.70.1.0 represents the main host IP address. So as you can see here, here 135.70.1.0 represents the main host IP address, as you can see here, and this will give internet to all the devices here. Now here let's move on to the subnetworks. The subnetworks are broken into different segments. 135.70.2.0, a network with devices like 135.70.2.2 connected to it. 135.70.3.0, another network with devices like 135.70.3.1 and 135.70.3.2 connected to it. Now let's move on to the application center or the end users. At the bottom, end users or application clients are connected to their respective subnetworks, and each device having a unique device IP address. For example, a client with the 135.70.20 network has an IP of 135.70.2.2. And another example is a client in the 135.70.3.0 network has an IP of 135.70.3.1. So folks, that's it for today. And if you like this video and you want to support us, please like, share, subscribe to our channel kaviwebdesigns. This is Babak signing off.